This conference will now be recorded.
Okay, perfect. Guys, good evening. I have to make a short video now because this morning we didn't have our business as usual session on continuation with advanced Python for machine learning and data science. So as you remember, we have successfully completed the Python basics, covering all the concepts starting from scratch with fundamentals, building blocks, and how Python can be accessed fully using list, file, string slicing, files manipulation, and while function, for loop, while loop, in operators, numpys. We have discussed various concepts that makes you fundamentally strong. After that, we decided to come up with machine learning advanced concepts for Python and data science. So today we are going to cover the next area of it. So when I say advanced concepts of machine learning, here we will be talking about various things, that is numpys, pandas, and in numpys you will be understanding how you can index and access numpy arrays. So you have taken a different route now. All these days you're talking about files, list, tuples. Now we are talking about arrays. You need to have a strong fundamental basics on how an array is built, how array is accessed, how array can be manipulated, and how arrays can be sliced and diced, how arrays can be transversed, what is one-dimensional array, what is two-dimensional array, what is three-dimensional array. Machine learning is all about mathematical functions running in Python plug and play process. In this plug and play process, when you do your exploratory data analysis, you slice and dice your data in various aspects. So you look at the data in one dimensional, you look at the data in two dimensional, you look at the data in three dimensional to come out of the experimenting the attribute combinations. So for that reason, you need to be very much aware of how you have to access and index the numpy arrays. Now, after that, we'll be completing the linear algebra with numpy. And once we understand the linear algebra with numpy, we'll be talking about basic operations of numpy arrays. After completing that, we'll be moving on to broadcasting with numpy arrays. Okay, and then mathematical and statistical functions with numpy arrays. Guys, if you complete this particular module in advanced Python concepts for data science, most of the skeleton which you need to adopt for your machine learning code will be available online. So this is very, very important for you. As a real-time data scientist, I can assure you, if you understand these concepts carefully, practically, and logically, then you can adopt the data science journey very easily with more comfort. You will have very less confusions when I explain some complex process. Wherever I implement the code, it's 16 hours. I always take Python modules and Python functionalities. So that is nothing but numpys, pandas, scikit-learn, TensorFlow. So please kindly focus and get the importance of it. And what is pandas? Once we are done with the numpy arrays, we'll move on to pandas. In pandas, we have various aspects. What is pandas? In pandas, we also understand about series objects and data frame objects and matplotlib overview. If you remember, when we were talking about matplotlib, Nitvesh has asked so many questions: why this syntax is used, why you're only doing this way, why you're not doing that way. So all those questions and anxiety will be covered in this concept, in this concept, I mean in this overview and in this modules. Okay, so I know I have covered this a bit, but I just want to recap. What is numpy? Numpy is nothing but numpy stands for numeric Python or numerical Python. It is an open source and it is one of the module of Python. This numpy provides a fast mathematical functions. Okay, now the complete mathematical ecosystem for Python is numpy, pandas, matplotlib, scikit-learn, and TensorFlow. Pandas is repeated. Let me take that out. So if somebody asks you, guys, one more thing, when you are updating your CV, do not hesitate to put you are a hands-on Python machine learning engineer, because we are covering each and every aspect of Python machine learning ecosystem. We are learning from scratch to the top of NumPys, Pandas, Scikit-learn, Matplotlib, and TensorFlow. So please, you feel free to update the required your known skills in the CVs. So here what's happening is, when I say the complete machine learning ecosystem, this ecosystem is only for Python. So when you are saying you're working for a machine learning project with Python, these are the components. For example, when you say Hadoop project, in Hadoop you have HDFS, Scoop, Flume, Yarn, HBase, Kafka, Zookeeper, like that. In this machine learning project, when you're working with Python, you'll have NumPys, Pandas, Scikit-learn, TensorFlow. That's the important aspect of it. I hope you understood that point clearly. Now, why are we using NumPy? Very good. NumPy makes your world, your machine learning world, a better place to live, a better place to solve complex business issues. How are you solving it? You're solving it by converting the data into an array format so that it will be easy for you to analyze or visualize or to make some samples and experiment on top of your data. For that reason, your array oriented program will help you. That is the reason we use NumPy. And NumPys are efficiently implemented multi-dimensional arrays. When I say multi-dimensional arrays, different people deal with in different ways. Initially, we'll start with one-dimensional array. Initially, we'll start with one-dimensional array for our testing, and later on, we'll move into two-dimensional, and after that, we'll be moving into three-dimensional. Okay. Now, like that, designed for scientific computation. When I say scientific computation, hope you guys have heard that for data science and machine learning, you need to have a solid foundation on statistics as well. So this statistics implementation is done by Python, and you need to know a few Python functions that does the statistics work, so you can import those modules and get your work done. Okay. The word scientific computation is just an example on how you use your statistical computations using Python, so don't worry about it. The next one is library of high level computations and functions. High level library means, see, for example, was you have a very complex mathematical problem to solve. How can you solve that issue? Very simple. You need to know which specific module or which specific method or which specific function within the Python can solve that. So that is nothing but library. In that library, you'll pick the function, which will pick the module, you'll pick the method which you wanted to solve the issue with. NumPy's main object is the homogeneous multidimensional array. When I say homogeneous multidimensional array, you can deal with 1D, 2D, 3D without any issues, but you need to understand how you transpose those vectors, matrices, and everything. Vectors and matrices again comes under the linear algebra concept, which we deal in the next slides. Okay. Now, what is NumPy? You understood NumPy, you understood why we use NumPy. Now let's understand what are the table of elements you have in NumPy. In NumPy, you have it has a table of elements. First thing is numbers, and all those numbers will be of same type, and it's indexed by tuple of positive integer. For example, if you have negative integers, positive integers, and floats as a list of numbers in your NumPy, it will always take the positive integer within that, so it will use that one as a positive integer index by tuple. Now, in NumPy, dimensions are called as axes. When I say dimensions are called as axes, in two-dimensional it is 2D, in three-dimensional it's 3D. The word D starts for dimensions. Okay. Now, the number of axes is called rank. If you have two dimensions, that's second rank. If you have three dimensions, that's third rank. If you have one dimension, that's one rank. Okay. To show you that practically, let me take a pen. Now, this is one axis. This is one axis. X-axis, Y-axis. So, what am I saying here? The number of axes is called rank. This is one axis. So this is 2 rank. Here I have only one axis, that is one rank. Here I have three axes, 1, 2, 3. So it's 1 plus 1 plus 1. So this is rank 3. So I would say rank 3, rank 2, rank 1. Perfect. That's how it works. Now, in the diagram, we can see 1D array, 2D array, 3D array. For two-dimensional, we can say rank of 2. So with this, we understood the basics of Numpy. Perfect. Let's move on. Now, creating a new Numpy array. Very simple was. Carefully observe, guys. Let me highlight this one. This is very important. I should have done it before the class itself. Perfect. Perfect. Now, here what's happening is you have np.array. How are you dealing with numpys? It's not just numpys, it's numpy arrays also. So when you are dealing with numpy arrays, you need to know how you are creating a numpy array. So the first thing is I create a numpy array using np.array. This np.array will create an numpy array from Python list or tuples. Perfect. The name itself says what it does. Second one, numpy's arrays can be created from Python list or tuples in the following way. Perfect. First one, np.zeros. To create an array with all zeros, the function np.zero is used. Super. Like that. If you want to use an numpy, if you want to create an array with all ones, the function np.one is used. Super. So there are two things here. If you want to create all zeros in a numpy array, just use np.zeros. If you want to create all ones in your numpy array, just say np.ones. For your comfort, feasibility, I have already done this one. If you see here np.ones 3.4, it creates it. If you see here, I said import numpy as np, and I said a equal to numpy.array 1 2 3, and I asked a type of a. What did it give? Numpy.nd array, means numpy n is 1, number 1, d is dimensional array. Like that, I said b equal to numpy as np dot array 345 type of v. When I say type of b, I got the same thing, numpy dot nd array. N is number 1, d is dimensional array. Perfect. So here observe carefully. I said 1, 3 comma 4 means 3 rows 4 columns. So 1 2 3, like that. 3 comma 4 again, I asked zeros. So 1 2 3 4, we have 3 rows and 4 columns. This is how you create multi-dimensional arrays or an array with whatever number you wanted. Okay, let me go back to the pointer. Now next part is continuation to our numpy arrays. Now what is np.full? How can you understand this np.full? np.full main purpose is to an array with a given value. Perfect. Now to create an array with given shape and a given value, np.full is used. I repeat the statement. If you want to use or if you want to create an array with a given shape means 3 rows 4 columns, like that, and with a given shape and given value, I have value 1 or 2 or 3 or 4, whatever. Okay, in that case I can use np.full is used. Perfect. Like that. np.arange. When I say np.arange, creating a sequence of numbers. So for example, when I say sequence of numbers, your numpy itself will create the sequence of numbers. If you don't want sequence of numbers and if you want to create random numbers, you can use rand. That's a different story. And if you can just say take my 1 2 3 and show it in a numpy array, it will show it. Like that, you also use np.zeros, np.ones. Here we are talking about np.arange, where arange will create sequence of numbers. As easy as it sounds. Very good. np.linspace. Linspace is nothing but this is creating an array with evenly distributed numbers. When I say evenly distributed numbers, this will return an array having specific number of points, evenly distributed between two values. The maximum value is included, contrary to the arange. In the A range, now try to understand the differences between np.arange and np.linespace. np.arange is creating a sequence of numbers. Done and dusted, you got it right. But the problem in linspace is it is distributing the numbers. The evenly distributed numbers will have a number of points, and in this number of points the maximum value is included, the contrary to the A range. In the A range the maximum value is not included. Okay, I'll show this practically when I talk about it. Now np.random.rand, now np.random.rand is used to create a random numbers. Okay, this will just create random numbers from 0 to that matter I can say from -1 to +1. It creates a lot of random numbers. Now if you take an example, I can take a 2 by 3 matrix and have random floats between 0 and 1. Makes sense. Now np.empty, when I say np.empty, it creates simply an empty array. In this process, to create an uninitialized array with a given shape, its contents are not predictable. So when you are dealing with empty array, you can never expect what contents are going to be because it is not an uninitialized array and the shape is not known, and you can also cannot predict the contents that are present um, in the np.empty. Okay, let me change the font here. Font looks a bit different. I want clean, everything should look like same. Perfect. Now this is also done. My screen is shared and the session is recorded. Super. Now let's see practically. Okay guys, now see, we are talking about this one. I said np.arange. Okay, I said 10 30 5. Now starting number is 10, minimum number is 5. What did it do? It arranged a multiple of 5, 10, 15, 20, 25. Now if you ask me, Amar, where the hell is 5 gone? I don't know. If you see here, np.arange is creating a sequence of numbers. Okay, now if you see here, the maximum value is included, contrary to arange. Means in linspace your maximum value is included, but in arange your maximum value is not included. Likewise, to be honest with you, the minimum is also fucked up. 5 30. Between 5 and 30 I get 10, 15, 20, 25. That is taken care. This is the important of np.arange. Now let's take another example. np.arange from 0 to 0.3. Here what is the minimum value? 0. What is the maximum value? 2. What it has done? 0.69, 0.369, 1.2, 1.5, 1.8. Now you can ask me, how can you say why it has taken 0.3, why not 0.2, 0.4, 0.6 like that? Here it is telling 0.3 is one of the element in the tuples. If I say 0.7, then there also it will take a sequence of numbers considering the tuples and takes the multiplication of that. So here minimum is 5. So 5 is ignored, max is 30, it ignored, it gave 20, it gave 10, 15, 20, 25. Like that. Here minimum is 0, maximum is 3, 0 it ignored. When I say it ignored, it said 0 point. That 0 point can be 0.1 also, right? Understand the difference carefully. Otherwise, you will confuse when you are implementing the complex machine learning models and data science algorithms. Once again, if you are comfortable on this one, when you implement the models, when you fine tune the models, it will be very easy for you. So take my words seriously. So now when I say 0 minimum, ignore kar, 3 maximum, ignore kar. So I can say 0.3, sorry, 0 is minimum, 2 is maximum, 0 ignore kar, 2 ignore kar. I can see 0.3 is one of the element in tuple. In such case, it takes 0.3 plus 0.3 0.6 plus 0.3 0.9, 0.9 plus 0.3 is 1.2, 1.2 plus 0.3 is 1.5, 1.5 plus 0.3 is 1.8. So in this case, the minimum value, maximum value is removed, whereas in linspace the maximum value is always included. Let's talk about in 2 minutes. Now let's talk about random. When I say random, it says np.random.rand. It is saying 2 by 3, 2 rows 3 columns, right? Row number 1, row number 2. Okay, column number 1, column number 2, column number 3. So you have 2 rows and 3 columns, right? The random numbers are taken and those random numbers are given as output for you. Super. Like that. Let's say np.empty 2 comma 3. When I say empty, it creates an empty array. Okay, when it creates an empty array, what it does is you cannot predict the numbers inside the empty array. Okay, now you need to understand how the linspace works. This diagram, carefully observe everyone. You know you're importing your numpy as np. Anything after dot is called method, which we discussed in our initial class of Python. So here this is start of the interval, here this is the end of the interval, and this one is the items to generate within that range. Okay, so just link this one with this one. Okay, so start is 0, go here, start is 0, perfect. Again, stop is end of interval, it is 0, it is 2. So start is 0, stop is 2, number is 0.3. So it takes a multiple of or matter of 0.3. Perfect. Let's implement the same logic over here. Again, what is the start? 10. Okay. What is the end? 30. What is the number? 5. So for that reason it has taken numbers. Okay. Nothing to confuse. The syntax itself will explain everything what we are talking about. Okay. Here is all the drawings. Let me go back to my pointer. So now you understood np.zeros, np.ones, np.arrange, np.linspace, np.random.rand, and np.empty. Right? Erase all the drawings. Go back to the pointer. Now, let me jump to the next one. Now, what are the important attributes of NumPy object? When I say important attributes, you need to know. What is my attribute? My attribute is 2 hands, 2 legs, 2 eyes, 2 ears, blah, 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 blah. Like that. Your NumPy object also has some attributes. That attribute is nothing but the components that make it fully efficient. So for that one, you need to know what is an endim. You need to know what is the shape. You need to know what is the size. You need to know what is the data type. You also need to know what is item size. So let's talk about it. We need to understand the various aspects of it. So first one is endim. When I say endim, first thing is the numpy's array is called nd array. Remember this. Whenever you are talking about nd array, that is numpy's array. N for numpy, D for dimensions. nd array means numpy array. Now, the important attributes of the nd array object are: first one, number of access. Number of access means again number of dimensions. If the number of access is also called as rank. Now, if it is 2-dimensional, it's 2 rank. If it's 3-dimensional, it's 3 rank. We discussed about it just one slide before this one. So, ndim is nothing but n dimensions. N dimensions is nothing but number of access. That is called ndarray.ndim. Again, nd array is nothing but Python's object or Python's numpy array. Now let's go first, let's talk the theory and then I'll show you the practicals. Again, I'm talking about nd array dot shape. Again, nd array means numpy array. Shape is nothing but the dimensions of the array. This is the tuple of integers indicating the size of array in each dimension. When I say in each dimension, in x-axis I have this many number of tuple of integers indicating the size. Likewise, I can also say in y-axis I have this many tuple of integers indicating. For example, when I say 2, it says, boss, it is two-dimensional. When I say 3, it's two-dimensional. So practically, we'll talk about next 1 minute. First, understand the theory, and then we'll jump into it. Shape is nothing but how many rows, how many columns you have in a layman word. And dim is nothing but how many dimensions you have, like that. Now, nd array dot size. When I say nd array dot size, the total number of elements of the array. Okay, the total number of elements of the array is called as size. So first thing you spoke about first thing you spoke about first thing you spoke about ndim. Second, you spoke about shape. Third, you're talking about size. This size is about the total number of elements of that array. Okay, practically I'll talk to you in 1 minute. Now, d type is nothing but data type. When I say data type, your numpy, is it int, is it float, is it tuple, is it string, what, like that. Now, item size is nothing but the item size attributes to return size of each item. Okay, now let's talk practically. I'll take a pen. Now this is my array. In this array, what do I have? I have only one row. Okay, but the nd array or ndim is 2 because this is first one, this is second one. Okay, this is called number of axes, number of dimensions. So for this bit it is 2. Okay, because we have taken two dimensions. X-axis is one dimension, y-axis one dimension. Okay, let's take for say let's take 2, but the moment you see the comma, that is one shape. Do you see comma here? Do you see comma here? So this is one shape and this is one shape. Perfect, that's good. Now let's talk about, sorry, this is one dimension, this is one dimension, that is called nd array dot end. Now let's jump into the shape part. In the shape part, this is one of it. Okay, here the value of nd array dot shape is 2 comma 3 because the way how it works is, one second, I have taken example here. Okay, shape means, here the way how I can explain is, I have two axes, x-axis and y-axis, but how many attributes I have in that? 1, 2, 3. So in each of the axes I have 3 attributes. For that reason I say it's 2 comma 3. Shape is 2 comma 3. At times 2 comma 3 means 2 rows and 3 columns. Okay, but the shape, if you are dealing with a nested tuple or nested nd array, you all have to see how many values are present within the one tuple or within the one nd array, I can say. That is how you have to think. Now if you are confused, just ask me. I would like to repeat the statement. nd oh, let me complete the size and then come back to you. Okay, let's complete the size and come back to you. So this shape and size are kind of synonyms and they both are interlinked, so you may confuse. So first let's talk about size and then come back there. Okay, now the size is nothing but total number of elements of the array. This is equal to the product of the element of the shape. Okay, so in here, observe carefully. I have an NP range of 1 to 5. When I say NP range of 1 to 5, what does it say? what does it say? It should show me something, right? That is nothing but it is telling the total number of elements of that array. Here, 1 array, 2 array, 3 array, 4 array, 5 array, 6 array. So the size is 6. Perfect. When size is calculating the number of elements within the numpy array, your shape is just doing how many shapes I have. Okay, now let me erase all the drawings. Let me go back to the pointer. I'm talking about this point now. Now, when your size is all about number of values or elements you have in each array, your your nd dot shape, let me take the highlighter here, highlighter spotlight. Can you see the spotlight? Anybody? Is spotlight working for you? Okay, I'll take a highlighter here. Now, likewise here, shape is nothing but I have, this is 1, this is 2. So I have I have 2 dimensions. Within the dimensions, each dimension has 3 values. First one, second one, third one. First one, second one, third one. Okay. Now, as you have 2 dimensions with 3 values across, you should not say 2 comma 3 comma 3. Okay, you should only say 2 comma 3. That's how it works. You may get a lot of questions around this. Amar, what happens if I have another one where I have only one column in that? We'll deal with all those anxiety questions later stages, but let's understand the concepts clearly. By the time we complete the concepts, I don't think you'll have any questions because the way we are approaching this one is from scratch. Perfect. Now, item size is nothing but the item size attribute will return the size in bytes of each item. Okay, go and check this example. I said np.arange 1 comma 5. From 1 comma 5, 1 is your minimum value, 5 is your maximum value. So you know how that arange works. So the size of the, it returns a size in bytes, so it's 8 it the value is 8 bits, or I can say bytes is 8 bytes. Now you understood about endim, you understood about shape, you understood about size, you understood about d type, and you understood about item size. Perfect. Let's move on, guys. This example is simple. This one and this one are nothing but this one here, this one here, and this one here. Okay, I just tried to show you an example process. Perfect. Let me erase all the drawings. Now let me go to the next step. I'll erase all the drawings and go back to my pointer here. Now, reshaping the arrays. How can you reshape your arrays? Converting your rows into columns, converting your 3 by 2 into 2 by 3, 3 rows 2 columns into 2 rows 3 columns, like that. How can you do that? You can use a function called reshape. The function reshape is used to reshape the numpy array. The following example will illustrate this. Okay, and in this one you also have another option, indexing and the numpy arrays. 1 minute, guys. Did I miss that slide? Okay, actually this is a different slide. Actually, I just got confused if I have ignored that slide or that slide is missing. I'll go and check and come back to that, don't worry. But for now, let's finish today's agenda and then go back. Okay, so till now you have understood how you can deal with item size, shape, dimensions, and various aspects of it. Reshaping arrays can be done in a different way using just a method called reshape method. Okay, let me show you practically. Okay, I will take my pen. Now this is an array which has 1 5 3 19 13 7 3. Now When I say a of 3, again it's 0, 1, 2, 3. A of 3 is 19. Super. Now, like that, when I say a2 of 5, again let me erase all the drawings. A2 of 5 means 0, 1, 2, 3, 4, 5. Now, second one will be 3, 19, 13. You know, last one will be ignored. We discussed about it. There is no difference between how the indexes are accessed in Python with the indexes accessed in the NumPy array. It is all the same. Indexes starts from 0 here also. Please be aware of it. Now, I say A2 is to 2. And here, let me erase all the drawings again. Let me take my pointer. Again, it's saying 2, 2, 2, 2, 2, 2. Okay. What happens is, one second. Okay. So here, what it is telling is, I want the last, from last, I want the second one. Okay. From the last second one, what do you have? You have 3. No, it's not 3 actually. One second. A2, what did I do? Okay. First of all, A2 is 3 because 0, 1, 2. This is perfect. Now, 13 comma 3 became because remove the, let me show you something. Here, what this guy is showing is, two, between every output I get, there should be 2 difference. So this is my first row. I take 3. Perfect. Now leave this one and get this one. Leave this one and get this one. For that reason, you got 3, 13, and 3. It says for every number I take, it should be between the second one. When I say 0, 1, 2, this and this will be taken. When I say 4, when I say 2 is to 2, this will be taken. When I say again 2 is to 2, fifth will be ignored and sixth will be taken, like that. Now, don't talk about multiples of 2. Talk about the indices. When I say indices, the Python indices. When I say Python indices, it's a NumPy array indices. Perfect. You got that. Now, here if you see here, I have 2 colons and minus 1. When I say 2 colons without any value separator, it will take everything. Okay. It has ignored 1 because, one second, let me erase all the drawings again here. Let me go back to my pointer. Now, if you see here, you got, one second guys. Okay, what it has done is this, I have 2 colons here, and in 2 colons I said minus 1. When I said minus 1, what it does is it reverses everything. You have 1, 5, 3, 19, 13, 17, 3. You have 1, 5, 3, 19, 13, 7, 3. Okay, this side to this side and that side to this side. That's what it has done. Okay, erase all the drawings. Perfect. Now you understood how the slicing and dicing works in NumPy array. This is nothing but reshaping. Okay, now let's talk about indexing, guys. Very simple. Well, 1 minute guys, let me not confuse you. One second. I'll take the pen here. This bit is explained here. Okay, we are good, don't worry. Now the function with reshape will be explained here. How does that work? Now when I say a equal to np dot arrange 6, it says 0, 1, 2, 3, 4, 5. Now this is a one dimensional, we all know it. So when I say one dimensional, it's one rank. Now I'm converting this one rank into two-dimensional with 2 rows and 3 columns. So what I'm trying to do here, have one, and this one must be converted into 2 rows and 3 columns, right? So what did I have? I have 0, 1, 2, 3, 4, 5. How can I convert this just one into 2 rows and 3 columns? I can just say 0, 1, 2, 3, 4, 5. Because of this, now I have got 2 dimensions, which is 2 rows, 1, 2, 3 columns. So this is how your reshape works. Hope you guys are enjoying the Numpy functionalities. If you go back and look at our code in the code, what we did for the machine learning end-to-end project, we have used these functions a lot. So now you should be in a position to connect those concepts with the practical implementation we did here. Okay. Hope this slide is also clear. Let me move on. Erase all the drawings. Go back to the pointer. Now, next one is difference with regular Python arrays. Okay, now let's go back and compare what we spoke in our NumPy arrays versus Python arrays. Okay, now if you assign a value to an ND array, it is copied across the whole slice. When I say whole slice, yes, it's a whole element, or it's a whole uh, array, I can say. Now ND array slices are actually views on the same data buffer. Perfect. When I say views, how many of you know about SQL Server database tables and views? Table is a physical appearance of your data across. Views is nothing but a temporary table which has only a schema, and then values will be referred from that table. Okay. Now, considering a views theoretical definition, your ND array slices are actually views on the same data buffer. Super. If you modify it, it is going to modify the original ND array as well. But in Python, it's not like that. In Python, we discussed about array, we discussed about strings, we discussed about list, and we also talked about which one is mutable and which one is immutable. Now here, uh, if you change one ND array slice, it's going to modify the original ND array as well. Now if you want a copy of data, you need to use the copy method as another slice. Okay, that is the reason why when we did the random sampling and stratified sampling, we have taken the copy of data n number of times. I still remember many of you have asked me questions, Anna, why did you take a copy again? Anna, why did you did a random sampling, why did you put a copy aside? So when you're dealing with Python, always remember within the slices means within the arrays, if you are going to modify something, it is going to modify the original ND array as well. When I say ND array, it's just nothing but your Python array. When I say Python array, that's different from your NumPy array. I correct my statement. ND array is not a Python array. ND array is a NumPy array. NumPy is from Python anyhow. So don't get confused between ND array and Python array. ND array is NumPy's dimensional array. Okay. Now, whenever you wanted to get a copy of data, simply use copy method. Okay, perfect. Now, in this process, if we modify the slice, it remains the same. Okay. So guys, let's talk practically on what we have been discussing now. Let's take this example. I said b equal to 1 2 4 5 7 8. So this is just an array in Python, not a NumPy array. Now when I say b1:3 is equal to -1, what it should do? it should replace first one, second one, third one with -1, but it won't do because it can only assign an iterable. Okay, because in Python, in your Python arrays, you cannot directly go and make the changes. From here, let's jump into ND array. ND array is numpy dimensional array. So here I have got 1, 2, 5, 7, 8. What am I saying? Please update my first record to third record as -1. What it did, it just replaced first one and second one with -1. This is 0, this is 1, this is 2. It replaced first one and second with -1. We all know the number 3 will be ignored, means it won't do any operations on the third one, which means when I say 3, it is talking about 0 a of 2. So however, what we are trying to prove here is when we try to make a change in the numpy array elements, it has reflected. Why it has not applied the same thing here? Because that's the difference between regular Python arrays and numpy array Pythons. Okay, now let's talk about slicing. Slicing is nothing but I have 1, 2, 3, 4, 5. Now a underscore slice is 1 to 5. This is 0, this is 1, this is 2, this is 3, this is 4. So when I say 1, 2, 5, 7 will be considered, fifth one will be ignored. Okay, now 2, 5, 7, 8 is a underscore slice. Let me take it here. 2, 5, 7, 8. This is the value stored in a underscore slice. Super. Now what am I saying? A of 1 is 1000. Perfect. When I say a of 1, again this is 0, this is 1. So 5 should be replaced with 1000. 7 is remains same, 8 remains same, 2 remains same. So the number 1 remains the same here again because I'm calling a. What is a? A is 1. The first one is 1. So what happened here? Your 1, 2 is fine. 1000 is replaced because you have sliced it, and after slicing it, the first index is replaced with 1000. That's what it is. Very simple. So this is the difference of how your regular Python arrays and numpy arrays works. Okay, perfect. That's good. Let me erase all the drawings. Let me go back to the pointer. Now, indexing multidimensional numpy arrays. Now, you talked about single dimensions. Now let's jump into multi-dimensions. In this one, it is straightforward and simple. You need to understand one concept. You already know what I'm talking about, but just a recap of normal arrays versus numpy arrays. Okay. Okay, boss. I told you an example already. Now, np.arange. Sorry, guys. Now I'll jump into practicals first. I said 12. When I said 12, it starts from 0 till 11. Reshape to 3, 4 means 3 rows, 4 columns. 1, 2, 3, 4. Okay, I'm bad in writing, so don't worry. Now, when I say 12, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, now I still have few more things left, but all you understand is how the reshape works. Reshape will shape your numbers into the required dimensionalities. Okay, I have one more. Actually, I said 3 rows and 4 columns. So this is only 3 rows and 3 columns. So I say 9, 10, 11 here. So now I got 1 row, 2 row, 3 row, 1 column, 2 column, 3 column, 4 column. So this np.arange of 12 will be reshaped to 3 comma 4. That's perfect. Now what I'm saying is rows, I'm creating a new variable rows underscore on, and I'm saying np.array of true false true. Now when I say true false true, that means it is a new function altogether. Okay, now I'm saying give me the rows on and all the values. So what it will do is important. So rows on is again one dimensional. Now guys, very simple. First one is 3 comma 4, 3 rows and 4 columns. That is your A. Rows underscore on is a new variable. That new variable is again one row, which is 1 by 3, because I have one row and 3 columns here. Now here what am I saying? Get me rows on, okay, colon nothing. What it will do? What will do? It will implement this 1 by 3. When I say 1 by 3, it first implements 1 rows and 3 columns, and then try to check what it has on the right hand side. Okay, I'll make it more easy. First of all, the way how this works is it checks for the row start index, row end index. Okay, this is the row start index, this is the row end index, this is the column start index, this is the column end index. Okay, let me erase all the drawings. I'll show once again. Erase all the drawings to not to confuse you. 3 comma 4, 1 comma 3, row start, row end, column start, column end. Perfect. This is what we understood. Now in here, let me go here. When I say 1 comma 2, I have 1 row and 2 columns. Here 1 row and all columns. Here all rows and 1 column. Now let's take it here. Now I am saying A of rows on. Now what is rows on? Rows on is 1 row and 3 columns. Are you all with me? Now in this 1 row and 3 columns, I am asking it to give me this bit and all columns. When I say row on, it gives me all the rows, right? How many rows I have? I have only 1 row. But how many columns it should give? It gives me 3 columns. Okay, even I am getting confused here. Let me make it more clear. 1 second. Sometime it happens. Let me put it properly. Let's take a pointer. Guys, it's very important. You are dealing with multi-dimensions, so it happens. If you understand this carefully, you're done. Okay, so you have 3. First let me take a pen. 0, 1, 2, 3, 4. Let's do it practically. Let's not worry about this one. Let's do practically. Let me open my Jupyter notebook. I'll show you what I mean to say. 1 second guys, I have to close this one. One second, guys. Multi dimensions are very important. Let me not confuse you. Let me open this one. Perfect. These are all done. I've shown you all these things, so don't worry about it. Now let me come back here. What is in my PPT? My PPT says A equal to np dot range, right? A is equal to, I have to run all this, otherwise it will fail. Okay, import numpy as np have to be implemented. Okay, A equal to np dot a range of 12. Perfect. Now I'm going to reshape it as 3 comma 4. When I said the 3 comma 4, I'll get 3 rows and 4 columns. Now I'm gonna call A. Let us break into slices and do it. Now perfect, I got this one. So this is 3 rows and 4 columns. Now I'm going to create a new row. One second, guys. I don't know why it has broke. Run. Control C, Control V. Okay, perfect. Now I'm creating a new column. Rows underscore on is equal to np dot array. Perfect. np dot array, and in that I'll set true, false, and true. Okay, true, false, and true. Okay, now let me show what happens. I'll just call rows underscore on. Now only two non-keyword argument accepted. I have to give it within the quotes. Okay, now if I say this one, now this is one array. Okay, now what happens is three-dimensional, 4 columns, one-dimensional, 3 columns. Okay, let me erase all the drawings. Let me go back to the pointer. In here I am saying a of rows underscore on, sorry guys, and colon space. When I say this one, I need all my elements to be coming in here. Okay, let me say what it does. I know why it is failing. I have to give a comma here. Okay, and after that I need to give some space to it, and I need to remove this space here. Okay, now now the reason why this is working is, this is showing this result is, I want you to link this one and this one. I know I have explained you last time. See here, you are asking one row and all columns like that. Get me all the rows from rows on, and get me all the columns of A. When I say all the columns of A, I need to get 4 columns, right? So A of rows underscore R will be inherited as the structure, and it will put the values of your A into that one. Okay, for that reason it is converted into 2 rows and 4 columns. This is how you need to deal with your multi-dimensional arrays. Okay, now hope you understood the concept clearly. There is nothing to break your head. We already covered this in Python, but as you are dealing with 3-dimensional, I try to make things more clear for you. Okay, now I also highlighted here, rows on means and rows 0 and 3 and then all columns. Rows 0 and 3 and then all columns, because row 0 and 3 means again 1 2, 3, 4, 5, 6. Like this, take your 0th row, take your third row. Okay, because true means 0, 1, 2. Okay, so what is happening here? Your row 0 will be considered, your third row will be considered, and second one will be ignored to that matter. Okay, like this you are asking your process to inherit the structure of 3 comma 4 and then understand row underscore 0 and give the result the way I want. Okay, that's what it is. Very simple. Okay, I explained very clearly here. Now let me read the slides for you so you understand what I mean to say. Okay, this is done. The format used while indexing the multi-index is array of row start index, row end index, column start index, column end index. Super. We can also index using ND array of Boolean values on one axis to specify the indices we want to access. Now, Boolean values is true or false. So here what I'm saying is I gave you a number and I asked you to put it in the three-dimensional and three rows and four columns. Like that, I can also index Boolean values. What is the Boolean values? True or false. Now, like that, you can also, let me highlight this one because this is where I messed up in explaining to you. Now, we can also index using the ND array of Boolean values on one axis to specify the indices we want to access. I want to access the 0th one and I want to access the third one. What do you know? You always ignore the last one. When I say 0 comma 3, I will take from 0, 1 and 2. However, my 1 is having false, so I'll ignore that. That's what it is. Okay, this is how I've implemented a little logical way of three dimensions to two dimensions. Okay, because here 3 comma 4 is 3 rows and 4 columns, here 2 rows and 4 columns. Perfect. This is what it is. Erase all the drawings. Let me come back to the 14th slide. In 14th slide, I'm talking about linear algebra with Numpy. This is very, very important. Here you need to understand the vector. What is a vector? Vector is nothing but it's the quantity defined by magnitude and a direction. Vector is nothing but quantity defined by magnitude and direction. In which direction are you going at what speed? Quantity, what quantity? How much is that weight? Magnitude, speed, in which direction? That's what it is. Now, a vector can be represented by an array of numbers called as scalars. Scalars means whatever the components that are making it a vector are called as array of numbers called as scalars. Perfect. Now, for example, take a rocket. It's going up at a slight angle. It's 17 hours. It has a vertical speed of 5,000 meters per second. It also has a slight speed towards east at 10 meters per second. Likewise, it also had slight speed towards north at 50 meters per second. So first it was at 5,000 meters per second vertical speed. After some time it has taken east at 10 meters per second. After some it took north at 50 meters per second. In this situation, if you wanted to represent this in a Numpy format of linear algebra, you need to take first one 10, second one 50, and the total velocity or the total speed at 5,000. So now if you put it here, 10 is on your x-axis, 50 is on your y-axis, and 5,000 is on your other y-axis. Okay, this is how you need to do linear algebra. This is more important because we will be implementing a lot of linear algebra concepts in our machine learning process. If you are poor with linear algebra, please stop learning data science. I'm very serious. If you are poor in linear algebra, please stop learning data science. Okay, because your machine learning models or mathematical calculations you make is depending upon the linear algebra fundamentals. So this is all I have for today. Sorry, I couldn't make this session this morning because I have other commitments last evening where I have been helping two students who is taking the interview calls. So that's the reason I couldn't take the morning session. I'm glad we finished the important concept today in the evening session anyhow. I'm going to upload this recording straight away, and I'll see you all tomorrow morning. And keep up your spirit. We are doing an amazing job. We are almost there. In just few more weeks, you will be in a good shape where you can write your own end-to-end machine learning program. Thank you all. I appreciate your commitment. See you all tomorrow. Thank you.